How are you, my dear students? Hope everyone is okay and fine. Still fine also. My dear students, in the previous class, we also explained about the smallest particle theory. Here's the smallest particle theory. We also know about the Dalton's theory. There are also the 5 points, also the Dalton's theory, and we also know about the how can the formation of H2O. Here's the formation of H2O. There are 2 hydrogen and 1 oxygen atom, and now we also learn about the atom and also the symbol. It's very important topics today. Please everyone see the book. Yes, from the previous lesson, you came to know that atoms differ from elements to elements. Now, the question in how many elements are there or what types of atoms are there? Till now, 118 elements. Please everyone underline these words. Yes, the 118 elements have been invented. Among them, 98 is found in nature. Here's the 98 is the found in nature, and the rest of 20 is artificially made elements, and 20 is the artificial elements. So in the total elements number is the 118. Every element has a name. To express that shortly and easily, we use symbol for each of them. Generally, symbols are expressed by the first one or 2 letters of the Latin, Greek or English name of the elements. In case of expressing symbols with 1 letter, capital letter is used. In case of expressing symbols with 2 letters, the first one will be in capital letter and the second one will be in a small letter. Here I just give also the first letter is the hydrogen, is the H. Here with the symbol is the H. 2 word or the 2 letter, here the 2 letter is the helium. This structure is the helium and also the 2 letter is the He. The lithium is the Li, beryllium is beryllium, but boron is 1 letter B, carbon is 1 letter C. In the next class, in case of expressing symbols with 1 letter, capital letter in used. In case of expressing symbols with 2 letters, the first one will be in capital letter and in the second one will be in a small letter. Now, please everyone turn the next page. Some symbols of atoms and their English, Greek and Latin names are given below. Here's the hydrogen. Hydrogen means H. Helium. Helium, the symbol is the He. Lithium, the symbol is Li. Beryllium is the symbol is Be. Boron is the symbol is B. Carbon is the symbol is the C. Nitrogen is the symbol is N. The oxygen is the symbol is O. Fluorine. Fluorine is the symbol is the F, and the iron. Here's the iron. Basically, that means not iron is I. Basically, it comes from the Latin words ferrum. Here's the ferrum, the iron, the another symbol is the Fe. Now we also next lesson. We also go to the next lesson. Here's the next lesson is the molecule and the formula. Here's the molecule and formula. There are the some hypotheses. We have learned that molecules are made of combining 2 or more atoms. From the formula, it can be learned with atoms a molecule contains. A formula is, in fact, a short expression of a molecule. A formula is written with the symbols of the atoms that form the molecule. Now, we will know about the rules of writing formulae and what a formula tells us. Note that the term formula is the plural form of formula. Yes, the formula, this structure is the plural number and the formula is also the single number. Please everyone note these 2 words. Now, formula for element. Generally, numerous atoms in solid and liquid elements stay together. They do not form any molecules. Therefore, there are no formulae for such elements such as sodium, copper and iron. For most of the gaseous elements, two elements combine together to form a molecule. Therefore, the formula of such elements are written by writing their symbols with 2s subscript. For example, the formula of oxygen is O2. Here's the oxygen, another double structure is the formula is the O2, and the formula of nitrogen is N2. Two atoms form molecules in some liquid and solid elements as well. Their formulae are also written by writing their symbols with 2 as the subscript. For example, the formula of bromine liquid is Br2. Formulae of some elements are given in the following table. Please everyone see very carefully this table. Here's the table, element, symbol and the formula. Here's the element hydrogen. The symbol is H and the formula is the S2. Nitrogen. The symbol is N and the formula is N2. Oxygen. The symbol is O and the formula is O2. Fluorine. Symbol is F and the formula is F2. Chlorine. Symbol is the Cl and the formula is Cl2. Bromine. Symbol is Br and the formula is Br2. Iodine. The symbol is I and the formula is I2. Formula of compounds. From a formula of a compound we know which elements or group of atoms and their ratio the compound is made of form. For example, H2O tells us that a molecule of water is formed from 2 hydrogen atoms and the 1 oxygen atom. From the following table, we will see how formula of compounds tell us about the atoms and group of atoms that form molecules of the compounds. Characteristics of compounds name, formula, name, atoms and group of atoms that form the molecule. Compound's name ends with IDE when it is formed that a metal, sometimes a non-metal and a non-metal. First is the sodium chloride. Basically, it's come from the NaCl. Na means the natrium, the another Latin words. The sodium chloride. Atoms, the group of atoms that form of molecule. Sodium and chlorine. Second structure is the calcium oxide. Calcium and oxygen. Potassium iodide. Here's the potassium iodide, the potassium and iodine. Sulfur dioxide, SO2, sulfur and oxygen, carbon dioxide, CO2. Here's the carbon and the oxygen. Sometimes a non-metal and a number of oxygen atoms form a group of atoms which acts like a single atom. When such group of atoms form a compound with a metal, the compound's name ends with ITE or ATE. CaSO4, calcium sulfate. Again, calcium sulfate. CaSO3, calcium sulfide. KNO3, potassium nitrate. KNO2, potassium nitrate. Na2CO3, sodium carbonate. And AlPO4, aluminium phosphate. Here's basically this structure. There's the pronunciation is the first structure is the IDE add. When the IDE add, basically sodium chloride, calcium oxide, is the pronunciation is ide. And again also the potassium iodide, sodium sulfur dioxide and the carbon dioxide. Again when is the pronunciation is the another name is ITE or ATE. Again I also repeat. Calcium sulfate, CaSO4. Calcium sulfite, CaSO3. Again I also read that. CaSO4. Basically this pronunciation is calcium sulfate. What is the CaSO3? There's the pronunciation is the calcium sulfide. KNO3. Again, I also repeat the KNO3, potassium nitrate, and KNO2, KNO2, potassium nitrate. AlPO4. Again, I also read down the AlPO4, aluminium phosphate, etc., etc. My dear students, again, please everyone, the next structure is the particles of atom, lesson 9. Here's the next structure is the lesson 9. Now, what's the meaning of the lesson 9? Atoms are small in size. They are so small that we cannot see them in empty eyes, not even with the help of microscope. But with the help of electron microscope, atoms can be seen. So, very powerful microscope they can help. Here it is the mentionable that with the help of electron microscope, we can have a several million times of large view of an object. Now the question is, can two smallest particles be found by breaking so small atoms? According to Dalton's atoms theory, atoms are indivisible, that means it cannot be divided. This opinion was widely recognized by everyone for a long period, but now it has been proved that atoms can be divided into many small proton and neutron. Again, three particles can be got from dividing atoms. They are electron, proton and neutron. In modern research, it has been proved that neutron and proton exist in the center of atoms and electron moves around the center in the circular orbit. Generally, the same type of atoms consist of equal numbers of electron and proton. My dear students, in the next class, we also explain about the particles of atoms, and today in the running class, we also explain about the atoms and also the molecule and also the formula and the atoms and symbol. Yes, the atoms and symbol, we also learn about the element, symbol and formula. I think that's enough, my dear students. Goodbye.